Hi, Charles Fader here with Hanby Environmental, and I'm with Randy Cook and Jessica Innocente Armstrong with OMG Solutions, and we are going to demonstrate for you the new hydrocarbon remediation paradigm for water. We're going to have water contaminated with 35 gravity crude oil, and what we're going to do is use our Hanby test kit to test that water to show you the contamination level, and then we're going to treat that contaminated water sample with ELMN8 plus for water, and we're going to remediate that water sample. So what we're going to do is use the Hanby test kit. We're going to add our water sample, then we're going to ultimately add our contaminant to the water sample, extract that contaminant, and then add our white catalyst powder to develop the color to see the contamination level. But we'll start by creating our split water samples. So we're using water here from the water bottle, get our 2 water samples created. Okay. Two drops of 35 gravity crude oil in each water sample. We're going to shake our water samples up to make sure that we have 2 duplicate water samples contaminated with 35 gravity crude oil. Okay. Now we're going to test our first water sample to see what the contamination level is before treating the other water sample. So again, the steps are: create your water sample, add the extract solvent to pull the hydrocarbon out of the water sample and into the solvent, then swirl it around and let it decant it off into the test tube, add the white catalyst powder, cap and shake, and compare to our pictures. So, okay, so we have our water sample prepared over there. Now we're going to add our extract solvent to our water sample. We're going to cap and shake or swirl around. What we're going to be doing when we're doing that is we are moving the extract solvent throughout the water sample, and it is creating the surface contact of the extract solvent with the hydrocarbon contamination that's in that water sample and pulling it out of the water into the solvent. And as you can see here, the solvent is no longer clear, which means it extracted that hydrocarbon contamination that was in that water sample. Now we're going to decant that extract solvent from the SEP funnel into the test tube up to the scribed line.
We'll shake it one more time.
Okay.
See a little water tied up in it.
Okay. So the extract solvent is heavier than water, so that's why we use a separatory funnel to separate. Once we've done that, extract solvent pulls the hydrocarbon out of the water into the solvent, and it separates the bottom because of its density. It's heavier than water. So we've done that. Now we're going to, Randy there was making sure that there was no water there in our stem before we release the extract into the test tube. Now we're going to release that extract from the SEP funnel into the test tube. And now we're going to add our color development reagent catalyst into that extract solvent.
Oh, it's not clear.
As you can see, the solvent is not clear. When a solvent starts, it's clear like that, versus now we've done our extract, so we can see that we've got that contamination extracted from that water sample. We're adding our color development reagent catalyst powder to that extract. We're going to cap and shake it, and we will see our contamination level of our water sample there. So as we can see here, we have got something that's off scale over here. It's dark to black there at 50 ppm, and we can see over here just from putting 2 drops of crude oil in that water sample that we're way over off scale over here. Actually, we can't even quantify it because it's over the max chemistry of 50 ppm for crude oil in water. So there we are. We know that we're something above 50. And we have the same water sample here as you guys saw us prepare by putting the same 2 drops of the crude oil into the water sample. So now we're going to use this 1 mil dropper, and we're adding the ELMN8 Plus, which is the remediation product for water. We've added 1 mil there into our sample, and we're going to remediate it by creating the surface contact by this shaking and swirling. What's going on there is the ELMN8 Plus is now moving throughout that water sample and coming in contact with that hydrocarbon that was in there, and it's breaking it down. And so ELMN8 Plus is a non-hazardous and non-toxic solution that when it contacts the hydrocarbon, in this case the 35 gravity crude oil, is nothing more than a bunch of hydrogens and carbons attached by bonds. It's breaking those bonds individually, and it's oxidizing. When oxygen attaches to hydrogen, it makes water, and when oxygen attaches to carbon, it makes carbon dioxide, which is why you see the foaminess that is taking place here. We have oxidized the hydrocarbon contamination and cleaned it up. So now, back to the Hanby method, we're going to add our extract solvent to our water sample, and then we're going to cap and swirl that around. Again, doing the same thing, we're moving that extract solvent throughout that water sample to extract any hydrocarbon that's in that water sample and pull it out of the water sample and into the solvent. And we're going to let it sit, and it's clearing up. So now we've got, again, the solvent at the bottom, and notice how the solvent is clear. But we're going to go ahead and release that extract solvent into the test tube up to the scrub line. And before we add our kit, let's go ahead and take a look at that extract solvent. And remember how, see how it's clear now? It doesn't have that yellow tint to it. Now we're going to add our color development reagent catalyst to it. Cap it and shake it. And as you can see here, let me go ahead and check it up a little bit more. We went from well over 50 ppm to, let's see here, where are we? We're definitely below, let's let it sit and accumulate real fast. There we go. We're right there around, I would say, in between the 5 and the 10 ppm, so you can call it, 7.5 ppm. So from well over 50, we don't even know what this number is because it's so dark. Back over there to below 10. Yeah. So there we have it.
Very good.